I'm going to focus on some things here with radicals that people tend to forget about or get mixed up on as they're doing bigger problems. So let's walk through adding and subtracting, and I want to bring your attention to the fact that these are adding, subtracting, but you have different things inside the square roots. So what you're doing here is adding and subtracting different things. So if you had x plus y plus z, you can't do anything. You're stuck. So what you have is something like 7x plus 4y minus 2z. You cannot do any adding or subtracting with that. However, with numbers, we are able to take the insides and we're able to rewrite them because each one of those square roots has a perfect square inside it. So 12 is 4 times 3. And because 4 is 2 squared, we can take a 2 out, and this becomes 14 square root of 3, 2 times 7. For the second one, square root of 18 is actually 9 times 2, and 9 is 3 squared. So 3 times 4 is 12. And there's the square root of 2. And now on the third one, that's 2. Square root of 75, you can look at as 25 times 3. And because it's 25 times 3, and that's 5 squared, the square root of 5 squared is 5. 5 times 2 is 10. Minus 10 root 3. Now when we're at this point here, you can see that 2 of them are the same thing. That's sort of like 14x minus 10x, which means now we only have 4 of them, except we have to write square root of 3. So we have 4 square root of 3 plus 12 square root of 2. The order does not really matter so much on these unless you want to take a calculator and figure out which one is actually larger. But that's acceptable as long as it's simplified as much as it can be without any shortening. You can't do any rounding. So you have to leave it as square root of 3 and square root of 2. The next thing to focus on here is making sure you're really comfortable with rationalizing a denominator. So the concept here comes from the a plus b times a minus b multiplying of binomials. Because when you have the same a in 2 places, same b in 2 places, and one of these is plus and one is minus, the middle terms cancel out, so you get a squared minus b squared. So what we're going to do is to look at this as an a minus a b, which means we need an a plus b, and if we do that, then we'll take care of all the square roots. They'll all cancel out. So, and that means we have to take this sign, which was negative, and we have to make it positive. So the conjugate, what's called the conjugate, which is the opposite sign binomial, here would be square root of 5 plus square root of 3. So I'm going to rewrite this, square root of 6 over square root of 5 minus square root of 3, and I'm going to multiply by the number 1. That looks like 1 to me. Same thing on top as on the bottom. But now, as a result, I can do some multiplying. On the top, I get square root of 6 times square root of 5, which is square root of 30. And I have square root of 6 times square root of 3, which is square root of 18. We'll come back to that. On the bottom now, I have square root of 5 times square root of 5, which is 5. I have square root of 5 plus square root of 5 times square root of 3, which is square root of 15. I have minus square root of 3 times square root of 5, which is minus square root of 15. And then I have minus square root of 3 times square root of 3 is 3. These two middle terms cancel out, and 5 minus 3 is 2. So on the bottom here, I have a 2. The only thing left to notice is the fact that this can be simplified. And so I have square root of 30 plus, that's actually 9 times 2. 9 is 3 squared. So the square root of 3 squared is 3. So it's 3 root 2 over 2. So this required using the conjugate, which is the opposite sign, multiplying it out carefully, simplifying, and then that's it. So the main thing is to remember this format, understanding and recognizing that. That allows you to rationalize denominators really pretty easy. Okay, let's take a look at a reminder about a couple of other fraction radical issues. One of them is that a fraction in an exponent simply means that that's the root. So what this is saying is the square root of 5 to the first power. We don't really need that one. So this is actually the square root of 5. We don't even usually write the 2, so I'll leave it like that. I don't think I really like that square root I did, so I'm going to redo it. Ooh, didn't mean it to go away. All right, I'll bring it back. Sometimes it doesn't cooperate with me. Let's see if it's any better. All right, good enough. Now here, we're going to do it where it's not a 2. Let's watch what happens here. I'm simply going to apply this method where that's the 4th root of 7 to the 3rd power. There really isn't anything I can do here with it. I will state that it's also okay to do it as the 3 on the outside. And so I'm going to take the 4 and make it the 4th root of 7 and then put 3 on the outside. These do the same thing. They're the same exact answers. So that means that this would be acceptable or this would be acceptable. Sometimes you do it one way or the other way based upon a problem that you're doing, where if you can have cubes in it, you can move further in the problem. And in other cases, you don't need to. So it's a matter of expediency, what matters to help you in a problem. Now, let's simplify an expression that has a number of parts to it, fractional radicals, and let's see what happens here. This kind of thing, don't really be thrown by it. Just start with the most inside part, follow order of operations, and follow things you've learned like this. So I'm going to take a look at a couple of things. One is I could make this the 5th root of x squared, but before that, if I apply the 4, it might do something for me. So I'm going to do that first. I'm going to do 3 to the 4th power, and then x, 4 times 2 is 8, so it's 8 to the 5th power. And then I have x, 7 to the 10th. That's really fine. So now one thing I've done is I've sort of taken care of the parentheses here. Now it says to do things on the inside, but except for rewriting x to the 2/5, there wouldn't be anything actual math-wise that I'm doing there. There's no transaction, there's no calculating something, just rewriting. In this case, doing it with a 4 probably works out better for me. So, and here's why. What I'm going to look at now is, let's look at what happens with these fractions. Well, 34 is an easy thing. That's 81. I'm going to leave x 8 to the 5th. I'm going to take this and bring it up to the top. And remember, when you bring a number or an expression with a exponent to the top, you change the sign. Or if you bring it down, you change the sign. So I'm changing the sign. But what I now have is two things. Like if I had x squared times x cubed, I would add these. So it would be would it add, subtracting? Yep, it would be adding. So it would be x 2 plus 3. So I'm going to do the same thing here, just with fraction. 8 over 5 plus negative 7 over 10. So actually that's 8 over, write this better. That's 8 over 5 minus 7 over 10. I need to make the denominators the same, so I'll multiply the first one by 2, 2 over 2. So it's 16 over 10 minus 7 over 10, and that is equal to 9 over 10. So that means that this part becomes x to the 9 over 10. And I'll write that under here. So it's 81 x to the 9 over 10. And then I can rewrite that depending upon what I'm asked to do. I've simplified it here. I can go one step further. Oops, I need to use this for that. 10th root of x to the 9th. This one's probably usually considered the more simplified one, but I'm not adverse to accepting this one at this point. So I'll accept both of these right now, unless it says different. If it says not to use fractional exponents in your answer, then do not, you leave it as a fraction, change it into the radical. All right, that should help with some of the things in this section. Thank you for listening.